Hello everyone and welcome to another episode of Threat Hunting Advanced Series. We will be taking a look at another threat hunting technique today. So without any further ado, let's get started. So the next technique that we'll be talking about is another one of the basic statistical technique that you would generally apply. It's called as simple as grouping. Right. So what we have here is a technique that focuses on traversing large amount of data or finding set of groups of event that have occurred around a single entity, right? So we'll just note that down. What it does is allows you to traverse large amount of data. It also allows you to actually explore data with focus on a single entity and explore occurrence slash events around it. Right, for example, what you would be doing is you can group by event dot action, and when you combine this with any one of the techniques such as filtering and searching, you get email or user dot email is equal to sakshamtushar@gmail.com. Right, so now all the results that you would get are in groups of event that happened around Saksham Tushar, or whether email is Saksham Tushar. Right, so you're not traversing data for around a single entity, and you're grouping them to understand if there's any particular event of interest. Right, you would, for example, this gave you authentic group of authentication events. This gave you groups of process load or start event. It gave you set of registry events and a set of DNS events. Right, it would come like authentication events are 10k, process load is almost 20k, registry events are say 500, DNS events are 2000. Right, now from this you would now go back into a feedback mode. Right, again you will go back to refine your actual query, which would mean if you go back and we are particularly interested in DNS, your next set of query would become group by event.action, where user.email is Saksham Tushar, group by dns.question.name, another event that actually defines, let me just quickly delete this subtopic. dns.question.name, where user.email Saksham.tushar. Right, so now we pivoted, we explored the data, we did some amount of traversing and exploration to identify what data are we actually interested in, and then from there we actually moved to finding event of interest. Now once you group by, you can again apply process of elimination as we discussed in the filtering and searching, or you can start clustering it, or start clustering would be a bad term. Clustering is a separate technique. What you would do is you would basically start stacking and sorting on top of it, right? So now once you have that, you can do stats count dns.question.name by, or since you're already grouping, you might have the numbers there, right? You can just do sort count descending, right? So once combined with stacking and sorting, you traversed, you took a feedback, you fixed, and now you are basically finding the outlier, right? So this is how this technique grouping works. Now a common problem or the common question that I generally face or people ask me is, hey, how is it very different from stacking and sorting, right? So if I had to say difference between stacking and sorting versus grouping, right? Stacking and sorting, and then there's another grouping. So grouping is meant for, let me quantify it in a term that is easy to understand. We use stacking and sorting generally to identify outliers in terms of occurrences, or in terms of, better put, highest, lowest, most common, or rarest events, right? You will miss the median events, right? Because it will be very difficult for you to traverse through that, right? Here, while the core focus is, we group to identify or build connections, chains, identification of artifacts that are around a common entity, such as a user, right? Such as a user, or IP, or domain, or hash, or whatever it is, right? You get it, right? So that is one of the primary difference. This basically would be actually be helpful for uh, frequency analysis, right? So for example, what you want to do is, when you want to identify high frequency events, such as scanning of infrastructure, right? Or you want to do a low frequency analysis, such as endpoint reaching out to a domain, right? Suspicious or malicious domain. This is the kind of technique that you would apply. In grouping, however, you are basically establishing relationships between elements, and this in turn allows you to pair high, or basically allows you to correlate indicators and signals, weak with strong, and yeah, that should be it. For example, you observed a domain connection, or you observed a process. For example, you observed a process event. You pivoted via process event to find a process called partial, and you pivoted, and you also observed while you were searching for the user, you also observed a process called Chrome, where parent is PowerShell. This might give you an indicator to correlate that user is launching Chrome, which is launching PowerShell, which is, say, a phishing behavior, right? And does you need to create a detection or a hunt or kill the process or do trialing, whatever it is, right? So you get it. How do you actually quantify or save in terms of the querying that you would do? For example, stacking and sorting, you would generally be doing commands that you would generally use are stats. You would do top, you would do rare, you would do sort, event stats. And basically you are working around statistics, which also means that we are working on frequency based statistical methodology or techniques, right? um, but here what you are doing is you are the commands that you would generally work with is basically um, again, you would use stats, but the notion is different. You would use, well, if you could think, you could group after joining, right? So that makes your data much more powerful, right? Now you have a stitched view on which you can join to find more related components, right? So in some terminology you would use join as well, you would do transaction, right? Some of these are commands. I think both of them, what I'm recalling from is both of them coming from Splunk environment. So if you're using a different language, probably these commands are not relevant to you. But anyways, that is the difference between stacking and sorting. Um, so the command or the technique is fairly simple. You group by, you explore, keep on putting. That is how you do. So we'll quickly jump into the demo and see how this can be executed, right? So we'll now quickly deep dive into the demo aspect and try to understand how do you actually practically use this technique, right? So I've got my elastic up and running here. And what I've done is I've curated a set of techniques, and I've emulated that over my Windows machine. So we have telemetry that would actually support practicing or demonstration of this hunt. So this time we are not going random and haywire. So if I had to just say um, the hypothesis is that will be running as part of the demonstration. We'll be doing unique destinations per user, and we'll see a modified version of the same thing, which is unique destination per processes. And this is going to be interesting because we'll get to see how each process, or where do each of our process communicate to, right, and the uniqueness in the domain. So what we'll do is we'll start writing the actual queries and see how that and what do we get, right? Let us start with a blank canvas. We don't have anything, so we'll be running in ESQL mode, as it's better to run clustering, grouping, all of these techniques in pipe processing or SQL kind of language instead of more of a filtering language, that is KQL. You can definitely do that using visualizations again in Elastic, right? Visualized library, you can go and do that, but better to do in ESQL. It gives you more granular control over data. So what we'll do is we'll just say let's say from logs hyphen star. Let's start to pull out, and we'll stats. Destination. Let's calculate all the destination. We'll do MB sort. If you're stuck and not able to understand what it does, you can just click on it and it will tell you uh, what does it do. Also, you can refer to the documentation, which I believe should be somewhere here. Yeah, ESQL help. Sorry. You can click on ESQL help, and this will show you the documentation, quick reference, all of that. You can search for a value or a command function, and it will tell you what it does, right? Sorts a multi-valued field in a lexicographical order. So we'll just use MV sort to basically sort unique values coming from a field called destination.ip, right? And we will also do a count over that, and we will say list count is equal to count distinct, which is again coming from destination.ip, right? And now we'll also do total events count, right? Total events equal to count star, and we'll do all of this by user.name, and then we'll pipe it to sort by destination count descending, and we'll also do limit 20, right? And let's run this for last 30 days. This would actually tell you these are the unique IPs to which these usernames have reached out to. Now you can keep on adding more filters, right? Where, for example, we want to say where destination.ip should not be equal to anything that you have in an infra, right? For example, you have a range of AWS IPs or you have a range of local network IPs. You can exclude all of that, and this is how you have grouped to identify per user, and this grouping would actually help you sort and navigate data faster. Another popular use case, as we said, is the modified version would be uh, process.name. What unique processes versus what unique destination in my environment. You would generally not want to do 30 days in a production environment. That would be too much of data to aggregate on. Probably to start doing by 10 days and then expand over when you start finding valuable entries. Game bar run DLL32. This could be an interesting pivot. You could probably pivot from here. But a single process reaching out to 355 unique destinations. You see most of them are 104, 114, 104.x.x.x. I don't know what this is in my environment. Probably will investigate later. But if you have a range that you already know of, you can exclude, and again, as I mentioned, do the process of elimination, right? You can also change this to do DNS.question.name, right? DNS.question.name. if I believe that field name value is right, this should tell me unique DNS, right? Unique DNS per process, interesting hunt, right? You could start identifying what unique DNS or domains were visited by each process or a user. If you're investigating a user, you have an insider threat case, right? What did the user visit to? This is, we'll just rename this as unique destination or unique DNS per process. Right, and then this is how one of the use cases look like. We'll go back and I'll just copy this. We saw a variant as well. The variant was unique DNS per process, right? And the query for that would be this, correct? Just remove this into. We'll see another hypothesis of a burst of discovery / enumeration observed in environment, right? What we are really hunting is an attacker doing multiple discovery calls inside your environment, right? He landed new, he wanted to understand more, so probably we'll start running a bunch of commands. If you try to do one command at a time, the problem is they are also done by some legitimate activities. But if you have a burst, or if you see a large amount in a small period of time, or if you see variation, large number of variations among these commands, probably something to investigate, right? So we'll start doing this. This is a bit complex. We'll take a new window and we'll start by logs. I have sysmon as well, and plus elastic defend data as well, so I can probably do a very targeted index search, right? For example, I could change it to sysmon operational, where all my sysmon data is, and I can do from there, I can do event code 1, right? I'm looking for all process start, if I'm not wrong, event code 1, and I would also want to provide some kind of filter to understand what kind of processes do I see as enumeration, right? So I can do and or let's do a new line and do and when log dot event dot or event data dot original file name. If this is correct, this should have loaded. Let me see if this is something that we have. Okay, when log dot event underscore data dot original we don't have that. Interesting, there are empty fields as well. I think this is what I remember, so let's try this. We'll do one net.exe. We'll bring the structure to the query first, and then expand. Net.exe is something I'll look for, and then what I'll do is I'll probably start doing stats, right? Aggregation is something, or grouping is something that we are learning now. So let's do stat. We'll say discovery tool count, right? The number of process invocation or the varied process invocation that we see. Discovery tool count is equal to count distinct, right? I will count the distinct of again. As per me, this is the right file field name value. So we'll say this, and we'll say also tool is used, right? It will again be this mv sort of values coming from file name. We have counted. What we have done is we have done count here. We have got unique values here, right? So you understand what we are doing is it is a number slash volume metric analysis. What we have here is not numbers. What we have here is actual values, right? So we do that. Execution count. Total number of time these were all executed per group that we will do, right? So what we'll see here is execution count equal to count star. As simple as that, right? And now what we'll do is we'll group by winlog dot event underscore data dot user comma host dot name comma time window equal to, now this is an interesting operator, bucket. Let me finish it off. I'll explain after that. Timestamp 5 minutes. As you can also understand from the language or syntax, what I'm doing is we are doing a group by 5 minutes. So the entire data would actually get chunked into buckets, even for a one user, right? It's one user per 5 minute, the new grouping that we'll be doing, right? So, and after that, what we'll do is we'll do a sort. We'll sort by time window, descending. We'll do discovery tool count descending, right? What we're doing, newest findings first, right? This should ideally work. Let me do that. Okay, line number 20, line number 220, where and my bad, it should be equal to cool. We'll run this 5.3. Let me fix errors. Okay, I think I forgot to add, right? I don't see any other error, so I'll just run this, and we have net.exe ran 23 times on this machine by this user, by this user. Now let me expand this. So we'll add the most popular tools. OMI.exe, what else, ipconfig.exe, we'll add nltest.exe, we'll add nslookup.exe. ARP is another good command that attackers use. What else? Netstat, of course, netstat.exe, And let me also do system info.exe and wmic.exe. I think that should be a good enough list. So we have a list of processes that attacker would use to enumerate. We have grouped them, sorted them, did a grouping on unique values, voluminous analysis, and volumetric analysis, and then we have sorted for first newest findings first, right? Run this very interesting data, right? We have ipconfig net stat whoami ran within 5 minute of window. So if you see, there's a 5 minute window, right? On a 5 minute window on the machine, which means this is how you actually start querying for bursts of event within small period of time, right? The Splunk query language would be very different from it. However, I'm using Elastic, so I've adapted the entire query or the example to how Elastic query language would look like. But I don't think it will be very different. If you want to translate, the language would be different, but translation should be fairly simple. If you're stuck somewhere, do ping me on LinkedIn, or if you also have any other sim, ping me and let me know what issues you are facing due to that. I can probably try to solve that for you, right? So what we did is we did a enumeration burst. Right, this is another interesting hunt. I think I'll stop here for now. I think we can still add on more examples to it, but we'll probably tackle them when I start dissecting actual threats, when we cover all of these threat hunting techniques, right? But feel free to practice. What I'll do is I'll give away the entire data set on my GitHub first, so that you can go and download it and ingest it in your choice of sim and start practicing all of it, practicing each of these techniques. What I'll also do is I've collated this and built the entire emulation operation or adversary in Caldera. So if you want, what I'll do is I'll give away even the Caldera operation, adversary and operation on my GitHub, so you can download this set of the actual adversary that works on set of abilities over Caldera and use it to simulate the similar behavior in all your machines, and then try to detect. So you will do end to end, from emulation to collection to actually hunting, right? But for most of you who don't want to do all of that, dataset would be available. Thank you so much for watching this video. Please do share and subscribe. I get a lot of motivation to create more if I see it is genuinely helping a lot of other people. I recently met a lot of people on other forums and we discussed, and I was really happy to see how these videos have helped some of them. So it keeps me motivated to create more, and even come out of my silo to share, right? So if you feel this is value add, share it on LinkedIn, do tag me, share it on WhatsApp, different channels, forums, wherever you feel this would be helpful for other folks. I would keep on creating this content and hope to see you in the new one. Thank you.